So far, this is our topic number 3. However, as the other week, before last week and the other week, we were talking about matrices. We were talking about matrices before. So we started with our first topic, that was graphs and equations. We defined what a function is. We talked about a linear function. Then we talked about inequalities, simultaneous equations, and how to solve simultaneous equations, and as well how to solve quadratic equations. That's what we covered. That's where we had the completing square method. We factorized and the quadratic formula for quadratic equations. Then for simultaneous equation, we had the elimination method. We have the substitution technique. We have the graphical technique of solving simultaneous equations. So then we came to the second topic where we are talking about matrices. We talked about several types of matrices. We had the vertical matrix, we had the horizontal matrix, we had the null matrix, we had the diagonal matrix, we had the singular matrix, we had the square matrix. All those types of matrices where we tried to indicate a 4x2, a 3x2, 3x3. We had all those matrices. We tried to come up to realize the determinants of these matrices. We tried to realize the determinants of these matrices. Mostly we focused on a 3x3 matrix to find the determinant. Then we have matrix application or matrices operations that involve the application of the inversion method or the Kramarau method. These are methods used to solve simultaneous equations using matrices. They are methods used to solve simultaneous equations using matrices. That is the Kramarau and the inversion method. I shared the videos about how we go about it. And today I wanted to get the feedback from the videos so that we can progress together. Faith Mutheu, have you gone through the videos? Because you are the only student on board. Have you gone through the videos for the matrices? So I shared the video for the matrices, and from the previous class, we agreed that we could pick up from there to get the feedback about the matrices and to try to understand how we can go about other stuffs. So I think that you have gone through that. You have gone through that. But I'm worried. Where are other students? So from the previous, we were trying to okay. So as I was saying, from the previous class, we tried to cover about matrices, and like the Harry and using the elimination method of solving simultaneous equations, also applying that solving simultaneous equations using matrices, we are supposed to arrive at this answer. Hope you were able to go through the videos that I shared with you. Nani hakupitia? Who did not go through the videos? I'm assuming that everybody went through the video and could be able to see how to solve simultaneous equations using matrices. But to make things work fast, I'm sending a question using the public chat. I want to see whether it was doable. So it is a simple simultaneous equation. We have 4x plus 3y, 4x plus 3y. Let me find a simpler question so that we can solve it as we move ahead. Let us have this simple one. The simple one, 2x minus 3y minus 3y equals to 8 minus 3y equals to 8. Then we have another equation. We are talking about 3x plus 4y equals to -5. I want to see you solve that equation using the Cramer-Rao method or the matrix inversion method. As I wait something here that I want to show you to come on board. So be solving that because I want to get whether we were able to go through. I want to understand whether we were able to go through and assume we understood whatever was taught to us. So let us be solving that. Don't use the substitution or the elimination technique. Just use the Cramer-Rao method or the matrix inversion method, whereby in the matrix inversion method, we need to find the minors. Then we are supposed to find the transpose for those matrices. We are supposed to come up with first with the minors. After coming up with the minors, we are supposed to transpose those matrices. Let us try to solve that. There's something I'm waiting to come down on board so that I can apply it. Use the Kramer-Rao method. The Kramer-Rao method is where we find the determinant of those matrices. Then we divide the determinants of the matrices, whereby we replace whereby we do what we call replace. Anybody who is able to solve for that? So we will be having our matrix 2, 3. We'll be having our matrix 2, 3. Then we'll be having a 3, 4. That is our initial matrix. 2, 3, 3, 4. Then we will be having x, y. Then the other matrix will be h, negative 5. There's something I'm waiting to come down on board. What's managed to find the value of x? So in whatever cases you may be given this equation, in cases where you are given two equations and you are asked to find the value of x and y using either the Kramer-Rao method, or sometimes you are asked to use the matrix inversion method, the best thing you do this thing is taking a lot of time. Okay, So I hope that you can get me from the other hand. Okay, we are trying to solve that, but I'm sharing something now. I'm able to go to whatever I wanted. So okay. So I got a video about that shows how we can go about that. And also I got another video showing about how we can go about don't know the problem, but I cannot be able to attach those videos so that I can show you how we are supposed to go about them. But I'm going to share the two videos with you as an attachment or added activities. But mainly today, okay, before I say anything, anybody with a question about matrix, because I want to talk more about matrices. Hello? Let me know people who are on board first. If you are on board, just say yes. And if you are not on board, you logged in, don't say anything. Those who are on board, Faith Nganga, Stella Mwenda, Sandra Nerius on board. Okay. So in cases, we have different ways of going about things, but let me show what I want to show you today about matrices. Then I continue, I move ahead. Okay. So this is matrices and a system of linear equations. A system of linear equations means simultaneous equations. So in cases where you have simultaneous equations, you can solve them using matrices. Okay, these are in a rectangular matrix, whereby where we have variables, you can see the matrix A1, A12, A13, up to A33. So it means that we had a matrix of 3 by 3. Then we had these A's and M's. Then we have Aij columns for the variables. That's not important. So you can see these are square matrices. From the matrix, we said when there's the same number of rows and same columns, we mean that when we have the same number of rows and same number of columns, they are square matrices. That's just a preview about what we are supposed to understand. And we talked about a diagonal matrix is a matrix with values in the principal diagonal. You can see this 1, 0, 0, 0, 1, 2, 0, 0, 0, 2. So the principal diagonal has 1, 1, and 2. Hope you went through the video. That's why I'm going so fast. Then we are talking about a scalar matrix. We are not supposed to teach about scalar matrices, but a scalar matrix is that equals to a certain element. It's like having a certain constant. So they are trying to use this matrix to show a scalar matrix. They are using an identity matrix, a 3 by 3 identity matrix of having 1, 1 in the principal diagonal. Then they are multiplying with 2. Hope you by now you understand how to multiply matrices. But if you have a question, you can be typing the question, because for me, okay, these are the types of identity matrix. Identity matrix have a determinant of 1. They have a determinant of 1, and they have an element 1, 1 in their principal diagonal, while other elements are 0. So for a 3 by 3, this is an identity matrix, 1, 1, 1. Then the other elements are 0, 0. Then for a 2 by 2 matrix, it is 1, 1. The other elements are 0. When you talk about a 0 matrix, all elements in that matrix equal to 0, like what we can see in that case. Then we have a negative matrix. A negative matrix has a determinant of a negative value, but that is not so important to us because nobody will ask you about a negative matrix. We have those, this is now whenever somebody now focuses entirely on matrices, that's when we have the upper matrix, upper triangular matrix. We have different shapes of matrix. The matrix can take any shape, but they are not important to have those types of matrix. How to transpose a matrix? So far, I think you understand how to transpose a matrix. When you are given, for example, here we had a row 1, 1, 2, then another -2, -1, 5. Then when you are supposed to transpose, you make this row to become the first column. It's going to be 1, 1, 2. Then this second row becomes the second column, -2, 1, 5. And this third row becomes the last column. It becomes 3, 4, 1. So how you transpose a matrix is that you change the row to become the column. That is how to transpose a matrix. And this will be so important in matrix inversion method of solving equations. The properties of transportation of matrix, they are not so important to us at this level. See, they are trying to show us the cases how to transport matrices using real variables. Symmetric matrices are so important, skewed. And what I'm looking for, I'm not seeing it. Whatever I'm looking for, I saw it somewhere, but okay. Here we have. Can you see? Are you able to see my page from your end? If you are, you can say yes, so that I can move together, because this was the most important thing I was after. This is what I want to show you guys. Are you able to see whatever I'm sharing? So we assume, for example, look at this first case. We have been given x, y. Stella Mwenda, you cannot see my sharing. Either you can't see what I'm selling or you can see what I'm selling. Don't know. The two of them, they do either. So, whatever I've said, nice Moi, can you mute your mic or I mute for you? Okay, so we have this first case. We have x, y, z equals to 1, 2x, 3y minus z equals to 2. Then we have this last case. I want to focus entirely for this first case. I don't want to focus, these are other simultaneous equations, but I want to focus entirely on this one. So expect to be given such type of simultaneous equations, the one we have here. So expect to be given such simultaneous equations. So I'm focusing on this side. I'm focusing on this side. This is where I'm focusing on. Hope you can see the equations I've circled. We have x, y, 2 equals to 1, 2x, 3, y, like minus z equals to 2, x, 2y, minus 2z equals to 4. So you can trace them down here to this side. So these equations can be written in matrix form. These equations can be exponented out to matrix form to have 1, 1, 2. So because here you look at this first equation, we don't have a coefficient. We assume that the coefficient before x times 1 is x times y is y times 1 is y, and 1 times z is z. So we assume that they have the coefficients of 1, 1, 1. So that's why this equation is indicated 1, 1, 1. Then this one comes outside here. You can see this one outside here. Then we have the second equation, 2, 3, negative 1. So we'll be having 2, 3, and negative 1. So whatever we have at this point, this is from equation number 2. Hope you can see that. Then from equation 3, we have this equation here. We have x, 2y, and 2z. This can be indicated, this has a coefficient of 1, this has a coefficient of positive 2, and this has a coefficient of negative 2. What you can see at the bottom here, we have 1, 2, negative 2. So we know the multiplication of matrices. We multiply row, we multiply column. Hope you remember that when you are multiplying matrices, you multiply the row versus the column. So for example, our first equation, if we were to work on it, it is 1 times x, which is going to give us the x. Then we are adding, because matrix, we normally add them. We are going to add x plus The second one is 1 times y. It's going to give us a y. Then we are going to add them. This is 1 times z. So it is going to give us a z. And this c is going to be equal to 1. So this is the same equation as the equation we have at this point. So for the second case, we are going to have 2 multiply x. It is going to be 2x. So it is going to be 2x. Then we are adding 3 times y. It's going to be 3y. Hope my handwriting is not that poor. Then we are supposed to add addition plus the negative, it becomes the negative. Then we are multiplying times z, it's going to be z. Then this one equal, we are going to equate it to our value here 2. So whatever we have in equation form can be indicated in matrices. That's what we have seen at this point. Are we together, guys? Up to that point, are we together? My students were not responding. If you have a challenge, you cannot see how this comes to this, you can be easily asked, because I'm trying to show you how these equations fall to form the matrices. So I've done the first 2 equations, this one and the second equation, so that I don't have space for the third equation, but I can do it on top here. So we have 1 multiply x, this 1 multiply x. Let me change the color. Let me use, yes, that one. So we have 1 multiply x, it's going to give us an x. And then we are supposed to add, then we are adding 2 times y, it gives us a 2y. It gives us a 2y. Then we are adding, but down here, we have negative 2. So negative and a positive, it becomes a negative. So it is going to be negative 2. It becomes negative 2z, which equals to what we have down here, 4. So it is going to be equal to 4. So this is our equation number 3. So we have equation number 1. So this is our equation 1. We have this as our equation number 2. We have that. Then we have this one as our equation number 3. Our equation number 3. So these equations can be transformed to the matrix form. Then we can proceed. Now we are trying to solve those equations. So come here now. You can see these equations. These equations, we have how is this person trying to do? Okay, but for me, I want to focus. What was this person trying to do? Let us go back to our equations. So let us progress from where we are. We are at this point. So the first thing we are supposed to know, we come with this our matrix. This is our matrix A. You can see they are indicated A, X, and B. So for our matrix A, we find the determinant for our matrix A now. So I'm going to erase everything so that I can come up for the determinant of matrix A. So I'm erasing everything so that I can come up with the determinant of matrix A. I'm focusing on coming up with the determinant of matrix A now. So our matrix A, this matrix here, look at it. I've circled the matrix A. The first thing you look at is to find the determinant. So we are looking at the determinant for that matrix A. The determinant for this our matrix A, we are going to add these two columns, these ones, the way I have circled them, we are going to add them at this point. At this point, then we are going to form lines. Let me change the color so that I'm saying that we are going to form columns. Yeah. So because we are adding this matrix to this side, we will be having 1, we will be having 2 at that point, we will be having 1 at that point. Then we will be having 1 again, we will be having a 3. That looks nasty. We will be having a 3, then we will be having a 2. So we will be forming this matrix in this way. So we'll be having such. Let me change the color. Then we will be having another one, 1, 2, and 3. So we'll be having those, of those who have written down this in their books, they can see, and they can be able to find the determinants. We can be able to find the determinants in that order. Then we come up, we find, after finding the determinants, you take the downward, you had these ones going down, the principal diagonals, you had them, then you subtract this other diagonal. You subtract them to find the determinant. After finding the determinant of a matrix, these are 3 by 3 matrix, we find the minor. Somebody can be asking how to go about the minor. Let me clear everything so that I can tell you how you go about the minor. So when you are at this point 1, in matrices we call that one A11. This is A11. This is A12. So it is the first, element in the first row, second column. So then we have this another one. It is going to be A13. So we are looking for the minor of A11. So the minor of A11, what we normally do, we assume that this column doesn't exist, and that row doesn't exist, and this column doesn't exist. Then we are going to have these elements 3, -2, and 2, -1. So we find the determinant of this small matrix, and it's going to give us the minor of the matrix A11. So in this case, we are going to have the principal diagonal as 2 times 3, 2 times 3 times -2. So we'll be having 3 multiply -2. We have 3 multiply -2. We are subtracting the other diagonal here. We have in bracket, we can talk about -1. -1 times 2. Hope you are able to see. This is going to give us a -6. Then we are subtracting a negative 2. Negative, negative. So our determinant is going to be negative 4. So this is the minor for this first element. So the minor for the first element is going to be negative 4. So we will be having a negative 4. We will be having a negative 4. Then we come to this A12. A12 is this second one. Also, it will cross that, and then for it, it's going to cross this one. So we will be having elements such as 2, negative 1, 1, and negative 2. Also, we find the determinants. We start by 2 times negative 2. So we will be having 2 multiply negative 2. Then we are subtracting negative 1 times 1. So we have negative 1. We multiply 1. So in that case, we are going to have negative 4 minus minus. So you have minus 1. So it is going to be negative 3. So we will be having another element, negative 3. Then we continue that way for all the elements. So assume we were at this last element, this one, we are going to cross that column and this row. Then we are going to have the elements as 1, 1, 2, and 3. Then we are going to have, we are going to talk about 1 times 3, that is 3 minus 2. It's going to give us a 1 at that point. So that's how we go about it. Then when we transpose, this is the matrix we are going to transpose. This is our new matrix. This one we are getting on top here is the one that we are going to transpose. It's going to be now negative 4, negative 3, and the other elements will be following on that. This one, they will be following suit. The other elements will follow suit. So that is how we go about it. Then when you are at this point, this matrix, after transposing it, we get the cofactor. A matrix is assumed to be positive, negative, positive, negative, positive, negative, positive, negative, and positive. So these are the signs of a matrix. So you come at this matrix, you have transpose, then you realize that a positive times a negative, it will be a negative. A negative, maybe it was a negative, it become a positive. So you have to make it a cofactor. After making it a cofactor matrix, after multiplying with this, then you are going to multiply with the values outside here. 1, 2, 4. Then you are going to come out with the values. Those values you are going to have, you are going to divide by them. You have 1 over determinant. That's why we started by finding the determinant. And the determinant you use is that of matrix A. Then we are going to get the values of x, y, and z as they are indicated in this order, x, y, and z. Anybody with a question up to that point? Anybody want something to be clarified? Anybody want something to be clarified? Anybody who did not understand anything? Anybody who has not gone through the videos I shared with you? Okay. Assuming that there is no question, let us come to the business of the day. Let me find a page that has nothing. So for them, they are trying to show okay, let me use this page. I'm not saying thank you, but let us talk about the business of the day. This is our new topic. So we are talking about a topic known as limits. Limits and continuity. So we talk about limits and continuity. This is a simple topic. This is a topic whereby somebody gives you, okay, the first statement I'm using, let me use the public chart I'm defining. I'm giving you an int. We say a function f is continuous. A function f is continuous at a point x equals to a, given it satisfies the following conditions. So there are three conditions that a function has to satisfy to be called continuous. So the first thing it's supposed to satisfy is that the function f has to be defined at neighborhood. I'm going to tell you what that means. That is the first thing. It has to be defined at neighborhood. Then number two, I'm using the presentation chart to illustrate number two. It means that fx, I know my handwriting is poor, given that x equals to a, this one exists. So this is the second condition that a function has to satisfy to mean that it is continuous. The first one, it has to be defined at neighborhood. Number two, fx exists. Fx must exist. Where x equals to a, it must exist. Then number three, the last condition that it needs to satisfy is that f of x, here we are talking at f of x, given that x equals to a, when you realize something is written as a subscript, it means that it is given. So it must be equal to f of a. So we are talking about f of x equals to f of a, given that x equals to a. So these are the three conditions that a function has to be satisfied to be called a continuous function. Are we together? I'm using a poll. If we are together, yes, no. I'm using a poll. If we are together, yes, no, because I want to see those who logged in and went away. Faith McKenna, what is it? Where are you lost? There's somebody called Felistas Gasheru, and there's somebody called Hilda Nyaguth. So we are talking about a function is said to be continuous if it satisfies the three conditions. The first condition it satisfies, it must be defined at a neighborhood. Number two, the function of fx must exist. Then we have the third condition that f of x equals to f of a, whereby x equals to a. Those are the three conditions a function must satisfy to be called or to be told it is continuous. Okay. Somebody is going to ask me, what about limits? We are talking about x equals to a. That means it is the limit. X equals to a, it is limited to that a. So let me take an example so that we can move ahead together. So let's take as example. We have an example. So we are talking about you have been given a function. You have been given a function. Let us call it f of x. And we have been told it equals to 2x. It is equal to 2x squared. Then you are adding plus x minus 5. So this is the function you have been given. Then you are told that x equals maybe to 3. So when you are given such a function, the first thing you are going to do, number one, you just simply substitute for x. So wherever you substitute for x, it's going to be 2 into 3 squared. Then you are adding 3. Then you are subtracting the 5 you have been given. What is the answer, guys? You can use the public chat to give me the answer. Me, I don't know the answer for that. Anapata jibu. Please let us be participating. Don't attend just the class for the sake. Do I have only 2 students? Come on. So it is going to give us a 16. So the answer is a 16. So we go back to our conditions. The first condition, we say it has to be defined at a neighborhood. When we mean that it has to be defined at a neighborhood, we mean that it gives us a finite. We say it's called a finite. It gives us a finite. It gives a finite value. That one means that we did not get something we call a mathematical error. Number two, the function of f of x exists. That is, it did not give us a mathematical error. It exists. And then when we just substitute for x with the value we have been given, we find another value. Faith McKenna? So for this now we normally conclude and say that our function is continuous. This function is continuous. I'm writing like a small kid. So this function, we say it is continuous because it has a defined at neighborhood. It also exists. Then I can give another example. Okay, Gidao, what is it? Even if you have a negative value, it is finite. Negative values are finite. The ones we would say They are not finite, they are infinite values, such as this one. We have negative infinity and positive infinity. These are the ones we say they are not finite, they are infinite. So this is the case whereby when you are using your calculators, you normally get mathematical error. Nelias, what is it? So I can give you an example that is going to give us an infinite value. I'm doing away with this so that I can give an example that can give an infinite value. I'm covering many topics today. I don't know why. Okay, you can't hear me? Come on. Guys, can you hear me from your end? Do you hear me from your end? Nelias. Nelias, maybe you'll connect, you come back to the conference again because others can hear me. It's only you who cannot get me. Maybe your device has a challenge. So we can take another example. An example 2, we have 1 over, so now you can check this one, x minus, let us say, 3. Then we are told that our x equals to 3. Assume that the function is h of x. We are assuming our function is h of x. So if we substitute for x in this case, we are going to have 1 over 3 minus 3. This one is going to give us 1 over 0. 1 over 0 equals to, umepata nini? 1 divided by 0 ni nini? Mathematical error? Guys, I want to see people using the public chat. 1 divided by 0 ni ngapi? Nani wamepata 1? 1 divided by 0 ni 1. Wow, 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 wow. When you get a mathematical error, it means that that is an infinite number, the number that doesn't exist. So in this case, we normally say it is infinite. So this one is where we talk about infinite. We call them the infinite. So this function, the first case, it is not defined at any neighborhood. Number 2, this function does not exist because it brings mathematical error. So we normally conclude and say it is discontinuous. It is discontinuous. So when a function doesn't satisfy any of the 3 above conditions, it is discontinuous. Then I'm going to do the last example. I'm going to do up to that point we are together. Then I have the last example that I'm going to do before I move on to another thing, because we have to complete today's task. I have a lot of videos that I'm supposed to share with you. So we can get another example. Another example, we can be told g of x is given as, hope you are copying down somewhere. You can be told x squared, then you are told maybe minus 3x. Then you can be told x minus 4. Then you are told that x, in this case, x equals to 2. Wherever you are told this, and you are told this is g of x, number one, you substitute these two in the two equations. So you can call this, let us call the first one equation 1, and the second one equation number 2. So when you get yourself there, you can start with equation 1. Equation 1, you can say about it, you substitute for 2. It's going to be 2 squared. Then you are subtracting 3 multiply 2. And that one, I think it is 4 minus 6. Which is going to give us a negative 2. What is the answer for equation 2? I'm not going to do it. Equation 2, I just want the answer. The answer for equation 2? The answer for equation 2, guys. So the answer for equation 2 is also negative 2. So what we conclude for this equation, number one, it is defined at a neighborhood. We have negative 2, negative 2. That's the first case. Number two, this function exists because it gives us a value at the end of time. Are we together? It gives a value at the end of time. It gives us a value at the end of time. So it is continuous. Then I can give you a trial sum. You can do wherever you go home. I know most of you, we had a class before with you and you don't like homework. I know you guys. But this one is a trial homework. So let me give you an homework that way. Let us take 16. That is 16. I'm sorry, my 6 is too small. Let me indicate it well so that somebody cannot say, I normally attend classes and I am taught small things. So we have 16. We subtract x. Then we have plus x squared. This is a plus. Then divide by, this is divided by negative 4 plus x. Then we are given down here 6. Then you are told x equals to 4. I call upon you guys to go and look at this. Then you can tell me whether it is continuous or it's not continuous. You can try that during your free time. I want to cover the next topic that I wanted to cover, because this topic about limits and continuity, I am advised never to teach it, but I like teaching it because it is so simple. It is so simple and sweet. It is so simple and sweet. So the next thing I'm supposed to cover is another topic it's supposed to be an assignment topic, but for God's sake, I rather teach it, then you can go and do more practice about it, because I want to take just 20 minutes of your time from now so that I can allow you to go through other activities under the course. So we'll be having another topic. It's not limits and continuity. Limits and continuity. These are just by this we are almost driven with the course. This unit is so small. We call it series. Series and sequence. Hey, poor handwriting guy. So we are talking about a topic about series and sequence. Somebody the other day asked me to differentiate difference between series and a sequence. So there's a time somebody can ask you to come up with a definition for series and a definition for sequence. So in cases where sequence, I'm using the public chat. For those who I'm not using the presentation area, I'm using the public chat to define a sequence is a set of numbers. It's a set of numbers arranged in a given a set of numbers arranged in a given order. That's what we refer to as a sequence. We can have 1, 2, 3, 4, all the way up to 10. Those are numbers arranged in what we refer to as ascending order. They are numbers arranged in ascending order. Also, we can have 40, 30, 12, maybe 5. We can say those are numbers arranged in a descending. They are numbers arranged in a descending order. We have also that case. So the sequence is the set of numbers arranged in a given order. They can either be in ascending order or they can be in a descending order. It doesn't matter. It is you to understand that a sequence is something. So we have what we refer to as an arithmetic sequence. Arithmetic sequence. And the arithmetic sequence in most cases you are going to find it is given a, comma, a plus d, comma, a plus 2d, comma, a plus 3d, all the way it will be up to a plus into brackets n minus 1 d. So an arithmetic sequence is indicated in this form, whereby a is the first value, the sequence. Hope you are taking notes. And the d is the common difference. Somebody can give you a series that is 1, 3, 5, 7, all the way. And so somebody can give you that as this is a series, a sequence. 1, 3, 5, 7. That's a sequence. Then somebody can ask you come up with the 10th number. So I'm using now the presentation area, the 10th value. So we know that an the last value of an arithmetic sequence is given by A plus, hope you can see whatever I'm doing, n minus 1 into brackets D. So this is the last value. But here somebody is asking you to come with A10. A10. To be precise, this person is asking you to come up with A10. Then A, we said from the public chat, I defined A is the first value of the sequence. We have a sequence of 1, 3, 5, 7. So our A is going to be 1. Then we are adding n minus 1. An, 10 is our n. So we are going to have 10. In this case, we are going to have 10 minus 1. Then the common difference, how do we get the common difference? We realize that A, our value equals to 1. The second number or the second value is A plus D. And we are told A plus D equals to 3. We know that A equals to 1. So 1 plus D equals to what? Equals to 3. So D equals to 3 minus 1. So our D here in this case is going to be equal to 2. So we are going to multiply outside here with 2. So when you are asked those numbers, you are going to come up with 1 plus, you remember the BODMAS rule, inside the bracket is going to give us 9. Then we are multiplying with a 2 outside. So it is going to be 1 plus 18. So our 10th value is going to be equal to 19. So from your side, guys, find for me the 12th value of that series. I want the 12th value of the series. The 12th value of the series. The 12th value for the series, please be faster. Time is not on our side. Time is not on our side. Be faster. The 12th value of the series. And I want to see the answers streaming in the public chat. Hope Faith McKenna, you can hear me from the other end now. I want to see the answers streaming in the public chat. I have 13 students on board and I have only 5 answers. There's some people who are not taking part in our class. There are some people who are not taking part in our class, and I've seen them. Okay. So that is how we go about it. Somebody can ask you up to 100 value. It is only that you have to understand how you substitute those values. So that is the first case about how we go about it. Then let me go ahead and do something else. I want to finish with arithmetic progression or arithmetic things, then I go to geometric. Although we are supposed to understand about harmonic, but I'm not going to do it in this class. Harmonic, we will do it for those who we will meet ahead in time. So let us talk about a series. I define the term series first, and define series as the sum of numbers in a given sequence. is the sum of numbers in a given sequence, assuming still we are having our sequence 1, 2, no, 1, 1, 3, 5, 7 as our sequence, and then we are told that this sequence has 20. It has 20 values. And you are asked to find the sum of the series. You are asked to find the sum of that series. I'm sorry for the 20 values. I'm saying it is 20 values. Then you are asked to find the sum of this series. So the sum of this series is just indicated as the sum is given as Sn. The sum of the series is always given as Sn. The sum of the series is given as Sn n over 2. Hope you are able to see. Then we have a big bracket 2a plus into bracket n minus 1. Then you are multiplying d, then you close the bracket. So it is given by 2a plus n minus 1 into d. That is how you go about it in that case. So when you are at that case, so we have been told that this series of ours, this sequence of ours has 20 values. So n equals to 20. So we are going to have S20. The sum of 20 values here is going to be given by 20 divided by 2. Then we remember that A is the first element, so we are going to have 2. Our first element is 1. We substitute with 1. Then we are talking about, you are adding. Here we are talking about 20. Subtract 1. Remembering that our common difference was 2. So this one, when you divide this, it becomes 10. When you multiply this, it becomes 2 plus, when you simplify inside the bracket, you get 19. Then this 19 is multiplied by 2. So using the principle of body mass, we would be having 10 into 2 plus, we are talking about here 38. Still we continue. I'm taking this thing to the top, to this point. So we are going to have 10 into 40. So we are going to have something like 400. So that is how we go about the sum of an arithmetic sequence. So I want you to assume the same sequence and assume that it has 8 values. It has 8 values. It has 8 values. So find the sum of the series. Assuming that it has 8 values, find the sum of that series. I want to see the answers streaming through the public chat. I want to see answers streaming. Assume that it has 8 values. I'm not seeing anybody typing. I want to see the answers from your end. The sum for the series. Okay, thank you. So using the public chart, now let me talk about the geometric progression. Geometric sequence. I start with the geometric sequence. The geometric sequence is always given as A, comma, AR, comma, AR squared, comma, AR cubed, comma, AR raised power 4, all the way to AR raised to power n minus 1. So that is how it is given. It is given AR raised to power 2, AR raised to power 3, AR raised to power 4, up to a point. The last value is going to be AR raised to power n minus 1. So I want to assume a certain sequence 1, 3, 7. I want to assume that sequence 1, 3, 7. Then somebody may ask me to find the 30th. Let me at least be logic. Let me find the 7th value. The 7th value of that sequence. I'm going to use the presentation area. Let me clear everything first. So when you are given such values, what you are supposed to understand that our A equals to 1. This is the first element. Then our R, somebody told me that is not a common difference. It's not a common difference, but it told me something about a common factor. We have AR in this case is given as 3. Then we are talking about AR squared. And I don't think that series is correct. I don't think that series is correct. It cannot be correct because there's something that is missing. It is supposed to be AR. So it is supposed to be, let us change. It is not 6. It is not 7. It is supposed to be 9. It is supposed to be 9. So I'm sorry, the series is 1, 3, 9. It can't be 7. The series is 1, 3, 9. So that is the correct series. So AR squared is supposed to give us a 9. So what we realize here is that from these two first, A and AR, we can find the value of R. R in this case is going to be given by 3 divided by A. And our A we know is equals to 1. So it is going to be 3 divided by 1. So which is going to give us a 3. And here we are asked to find A7. A7 is our value of interest. And we know that AN, let me use AN equals to AR n minus 1. So here we are talking about A7. So we are going to have A R 7 subtract 1. So we are going to have A7 will be given by, we have our A as 1. And remember that that 1 is not raised to power any power. So we'll be having 3 raised to power 7 minus 1, which is 6. So this is in short A7 is equal to 1 into 3 multiply 3 multiply 3 multiply 3 multiply 3. This is a 3. Multiply 3 multiply 3. So when we do that, it's going to be our A7 is 8 times 3 times 3, this is 9, times 3, that is 27, times 3, that is 81. 81 times 3, that is 243. 243 times 3. 243 times 3. This 9, 2 carry 1, that is 729. So it is going to be 729. So I am assuming that is from my side. So I am asking you guys to find A10. Find for me the A10th, the 10th value. Find for me the 10th value for that series. Please do so. Find for me the 10th value. I want to see the answers streaming via the public chat. I want to see the answers streaming via the public chat. Guys, I want to see the answers. Wow, 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 wow. They are giving two large values. So that is how we go about calculating the values that you may be asked. Any value that you may be asked, that is the formula you use. That is how you go about it. I don't want even to make an assumption to do that. So let me conclude by talking about geometric series. Geometric series. I want to conclude by talking about the geometric series. So how we sum about the geometric series, that is what I'm concerned, or geometric sequence, how we sum the geometric sequence. So I'm talking about the geometric sequence. So the sum of a geometric series, the sum of a geometric sequence is given by Sn equals to A into bracket 1, we're going to add plus r plus r squared. I'm using raised to power 2 plus r raised to power 3 plus r raised to power 4 all the way plus r raised to power n minus 1. So that is how we go about the sum. So assuming the series we had that was 1, 3, and 9, then somebody tells us the series as, let us say the series as 6 values. We are talking about 6 values here. So how we go about it, we know that our A equals to 1 and our R equals to 3. So when we are told to find Sn, so S of 6, because we are looking for the sum of 6 values, we are going to have our A into bracket, we are going to have 1, we are going to add this R plus R raised to power 2 plus R raised to power 3 plus R raised to power 4 plus R raised to power 5. I stop at R raised to power 5 because the last value we talked about R raised to power n minus 1. So it is going to be R raised to power 5. So in that case, we are going to have A is 1, then we are going to have 1 plus, we are talking about 3, then we have 3 raised to power 2 plus 3 raised to power 3 plus 3 raised to power 4 plus 3 raised to power 5. Somebody with the answer? So we will be having 63 plus 9 I want to see. Cross forward, in cross. I'm good. Yes, and somebody to give me the answer for this. Please, somebody do it for me this. I don't have a calculator. I'm using the presentation area. 1 into 1 minus 3 raised to power 6 out of this divided by 1 minus 3. Somebody to give me the answer for that. 1 into 1. Somebody to help me with the answer for that. Help me, please. 1 into 1 minus 3 raised to power 6 over 1 minus 3, that is negative 2. Please help me. Okay. If it gives 364, then there is a divide by 2 Felisa Gashero. There is a divide by 2. Felisa Gashero, there is a divide by 2. Negative 2 still, it's a negative 2. If it gives the same answer, it can't be negative Steramwenda, because on top we have a negative and on the bottom we have a negative. It will be a positive. It will be a positive. Okay, thank you. So I've discovered a formula for that. So instead of going all that, we can find S6. S6, the formula can be written down as A into 1 minus R raised to power 6 divided by 1 minus R. So these are the formula. This is the formula. This is the formula. You can use this formula. So to capture it well, I'm going to erase everything, but this is for S6. So the formula for going about the sum of the sum. So I can simply say the sum of a GP. GP means geometric progression, is given as Sn equals to A into bracket 1 subtract R raised to power n close the bracket, then we do. So this is the formula. This is the formula. So up to that point, I have covered my business for the day. And I want to give you the remaining 1 hour so that you can go through all the activities under the course. Although I'm going to attach some other videos so that you can be able to catch up with. Any question before? Any question? Somebody who missed something? So if there's no question, I have recorded the tutorial for the class today.